What's up guys, how are you? My name is Glauco Pires and welcome to the Fruit Ninja game development course in Unity. This is going to be a great course because you're going to learn lots of things on how to make a nice Fruit Ninja game. So we're going to learn how to work with interface in an interface that can be resized and respond correctly to different screen sizes, learn how to work with buttons, and of course work with the actual game logic, making a score counter, making fruits appear, and cutting the screen and see these red lines when we do so. Okay, if you cut the fruits, you're going to get 10 points for each of these fruits, and if you cut the bombs, you lose a life. Okay, if I cut another bomb, it's going to be game over. We see the final score, and we click to play again. So this is the basic logic. So I've been working with games since 2010, and I've worked with several different technologies. Unity is the one I have the most experience. I've been working for since 2010, but I've also worked with Unreal, with Phaser. I've worked with several different HTML5 technologies as well. So I'm going to share this experience with you throughout this course in different topics. So one by one, we're going to learn one different game development topic, one right after the other, and we're going to build this entire game in around 2 hours more or less, and also how to optimize and make a very organized code and very organized hierarchy. Okay, so this is it. I hope you're excited to start this course, and I see you soon. Okay, so the first step as usual is to start a new Unity project. Let's open Unity. We're going to click on the new button, and then we have to set the project name, location, and rendering mode. So to start, we're going to use here Fruit Ninja. The location of the project, what I usually do in my courses is, here is my home folder, and I make a projects folder right under it in the hierarchy. This is important for you to keep your files organized and don't just mix things with the downloads, documents, or desktop folder. Make a folder just for your projects. Okay. And then as for the rendering mode, instead of 3D, we're going to use two-dimensional mode. Okay. When you select one of these modes, it doesn't necessarily mean you cannot use the other one. It's just Unity is going to set up with a few presets based on what you select. We're not going to need any extra asset packages, and after we do this, we just press Create Project. So we're going to wait just a little bit for Unity to start, okay, to have all the files needed to make this work, and then we should be good to go. Okay, and before we move forward, we already have some art assets ready for us, so we want to import them in this project. So what I'm going to do is I'm going to open the folder where this project was created. You can just right click here in the assets panel and choose Reveal in Finder, so you go straight to its folder. And also I'm going to open in the downloads folder this zip file, Fruit Ninja Art. You should be able to download this in your course directory. Okay, I'm just going to expand this to have this folder, and notice that we have two folders here, fonts and sprites. I'm going to copy them. Okay, just right click, choose copy. Doesn't matter if you're on Windows or on Mac OS, it works the same way. And here in the assets folder, I'm going to right click and choose paste. Once we do this, just go back to Unity, wait a little bit, and all the files are going to be here. Okay, that's everything that's external from this project from Unity that we need to use. Okay, so in the fonts folder, we're going to have this Shojimaru folder, font, and sprites, we're going to have a few different sprites. Okay, now this is a tip for you when you're making bigger projects, but still it's important to do this in smaller projects. I highly recommend you to here in the assets folder to right click, create a new folder, and name this project. Then we got fonts and sprites, and we're going to put them inside it. Some of you might be saying, hey, that's completely not necessary because, well, this is our project, this is our game. Why do I make a project folder inside my own project? We do this because whenever we add external assets, external asset packages from the Unity store or from anywhere else, any plugins that we do, all of them, they're going to be here in the root folder. So it's very interesting for you to put everything regarding your game, everything that you are creating in a project folder, so you ensure that anything that belongs to any third-party app is going to mix up with your things. Okay, so we just have fonts and sprites here. This is the basic setup that we're going to do here. It just takes a few seconds, a few minutes to understand why we do this, but this is going to make a huge difference in the future. It's just going to make things easier, okay? And first of all, we want to make a scene here. Okay, this game is going to have two scenes. We're going to have a title scene, which works as a main menu, and we're going to have a game scene. Okay, so in the start scene, it's going to be something very simple. We're going to have a basic background here, just standing still. We're going to have a title for our game, and we're going to have a play button. Okay, so we're going to do all of these things. First of all, if you have never worked with Unity interface, you're going to see how simple it is. Okay, here in the hierarchy, I'm going to right click, then choose UI, and then Canvas. The name Canvas is very interesting because it literally means that you are painting in a canvas, in a transparent canvas. And whatever you add to this canvas is going to be drawn on top of your game. So if you have 2D elements here, if you have 3D elements, if you have a huge terrain in Unity, it doesn't matter. Whatever you put in the canvas that's related to user interface, it's going to be drawn on the top. Okay? And if you select the canvas in the hierarchy, you're going to notice that there are lots of settings here in the inspector. But what we want to look, you see you have some components here. You have rect transform, canvas, canvas scaler, graphic raycaster, but these are the most important ones, these two. You have canvas and canvas scaler. First of all, if you select the render mode, you're going to see that it's saying here screen space overlay. But for this game, we're going to use screen space camera. Okay, this specific setting is not going to make a huge difference in this scene, but it's going to make in the other one, and you're going to understand why. Okay, but still, you're kind of converting how this is going to be rendered by using the scene camera, the main camera that you already have here. Okay, so back in the canvas, you notice here that when you select the screen space camera, you need to pass a camera as a parameter here. To do that, we're just going to drag the main camera and drop it here. Okay, that's all. Okay, so the camera is kind of going to be attached to this canvas, and everything related to the game is going to be rendered here. Okay, but still, we have other settings here, the sorting layer, ordering layer. We're not going to change these things, but here in Canvas Scaler, we're going to change things. Okay, this is very important if you want to make your game responsive, if you want your game to behave correctly in multiple resolutions and different devices and different aspect ratios. Okay, so right now you have the UI scale mode set as constant pixel size. We want to change this. We want to use scale with screen size. Okay, so if the screen size changes, if you play on a full HD device, or if you play on a device with a smaller resolution, it's still going to scale along with it. Okay, it's going to work the same way. It's going to look good. If you don't do this, if you run this game in a high resolution, it's going to look very odd because the interface might get too small. So it's important for you to care about how you make your canvas right in the beginning of your project, like we are doing right now. Okay, so we want to scale with the screen size, and we want to set a reference resolution. For this project, we're going to use 1280 for X, and for Y, 920. As for the screen match mode, it's saying here match width or height. This is very interesting. Okay, why? I'm going to the game window here, and I'm going to set the aspect ratio to 4:3. It looks like this. The way we are developing this game is we want to play it in landscape mode. Okay, however, notice that here where it says match, it's showing width. Okay, this slider here is all the way to width. The problem is if we leave it like this, if you play this game in a 16:9 aspect ratio, for example, then things are going to scale, but that's not what we want to do. We want to scale only with the height. Okay, for a landscape game, we want it to scale with the height. For a portrait, with the width. Okay, but still, since we're using landscape mode, okay, we're basically going to use these two aspect ratios, 4:3 and 16:9. We want this to match the height completely, so we move the slider all the way up to height, or we just type 1 here. Okay, and these are basically all the settings that we have to do for the canvas. You don't see any immediate adjustments, any immediate results by doing this, but still, again, it's very important to understand how this works. Once you make your game, you can try fiddling with these values here, changing their numbers and settings to see what happens whenever you scale your game, okay? So back to the scene window. Now that we have a canvas, we basically want to add a background, something very simple. And there are a few different ways to add the background. The one that we're going to use is here in the canvas. I'm going to right click. So whatever I add when I'm right clicking here in this canvas and I have it selected, it's going to be under the canvas in the hierarchy. So we go to UI here and then image. So we have an image inside the canvas. Notice that the canvas is going to render all the user interface game objects, which are these ones here that you have. Okay? And once you add this image, you're going to notice here in the scene window that we just have a white square. Okay? We need to change the source image. We need to change the sprite that is going to be rendered in this image. So in the project window, in the project folder as well, we go to the sprites folder and we have these sprites for us. Okay, sword, fruits, button, bomb, and background. And background is the one that we want. There are two ways to do this. You can just drag the background and drop it here in source image, or if nothing is set here, you can just click on this circle and you're going to see all the valid files in your project. Okay, I'm just going to use background. And again, you notice that the background is too small, it's still a square, but you can quickly set the correct resolution for this background by clicking on Set Native Size. Okay, so the entire background is now fitting the screen that we made with the resolution that we made. Notice that the background has a height of 923 and our canvas also has a reference resolution in its height of 920, so it fills correctly vertically. And if you look at the game window, you can see that the background is fitting the entire area. Okay? Now that we have this, we want to add a title. Okay? Something very simple just to say the name of the game. Here in the canvas, I'm going to right click, choose UI, and then text. Okay? You can't see the text here in the game window because it's too small. You can see a very short blur here. So we go back to the scene window and we can see the text better. Okay? Notice that if you use this tool here, whenever you're dealing with user interface elements or other elements as well, you're going to see these blue knobs here. Imagine you're editing images in Paint or Photoshop or any other image editing software. You can quickly resize things by just clicking on these knobs and dragging them around. Okay? And if you click here and you hold the Alt or the Option button, you're going to resize it in an even better way. Okay? It's going to keep mirroring whatever changes you do to one side to all of the other three. So we're going to increase its size to give a lot of space for this text that we're making. I'm going to change this text to Fruit Ninja. However, I still can't see it, but we're going to change this font size here to 64 or maybe more. Let's use 70. Okay, this is the title. It deserves a lot of space. To change the font, I'm going to click here in the circle and select Chojimaro. Good. And the color, I'm going to use either white or black. I think white looks better here. Okay. So white color. The alignment, we're going to center it horizontally and center it vertically. So it's going to be in this place. And I'm going to move this little box up here so you can see the title. And increase the size as well. Okay, don't be scared to use large numbers in the font size, because when you do this and you look in the game window, it's going to look much better. Okay, so that's all we need for this text. Now, before moving on to working with the play button, I want to talk about another thing. Let's say you want to put a very small credit here. You want to say, hey, this game was made by me. Okay, so we're going to make another text. First of all, let's rename this to title text. And here in the canvas window, I'm going to right click, choose UI, then text again. Okay, let's increase its size. Doesn't need to be as big as the Fruit Ninja one. We're going to put here a game by and then John Doe. Okay, we don't know your name yet, but you can just replace this with the name you want. I'm going to put this text in the bottom right. So it's interesting to change the alignment of this text to the right horizontally and down vertically. I'm going to change the font to Jojomaru as well, and the font size to 40, maybe 30. No, 30 is better. And I'm going to change the color to white as well, so this is easier to see. And I'm going to position this here. Okay, so if you look at the game window, it's looking like this, a game by John Doe. Okay, great. However, there is a problem here, and it's important for you to know about this when you're dealing with interfaces. Right now, we are simulating a 4:3 screen. Okay, it's a bit square. But if we change this to 16:9, you're going to notice that this text didn't move. Okay, it's still in the same place. While it doesn't make a huge difference with this little text, it might make with the user interface. Okay, if you have a wider screen, you want the elements to be distributed better. Okay, we don't want them to stand in the same place like it's doing right now. So what we're going to do is something very simple. We're going to work with anchors. When we have the text, or when we have any element inside the canvas selected, if you look at the rect transform component, you're going to notice that there is this little square here where we can set how the anchoring for this works. Right now it's set to the center, so it's basically not going to move automatically. It's independent of how the canvas or how your screen works. But if we click here, we're going to see lots of presets that are going to really help us. And what we want to do is, hey, we want this element here to be anchored to the bottom, which is this row here, and to the right, which is this column here. So bottom right, it's this option here. You notice that there's a little X that's pointing to this place here. And now if you go to the game window and you change from 4:3 to 16:9, 16:10, or 3:2, whatever you want, the text is going to follow this. Again, it's not a huge difference in this game, but still this is very important knowledge for you, so you can learn how to make interesting and complete interfaces. Okay, and now to finish this, we need to make a very simple button. We just want a play button that when you click, you're going to move on to another scene. Okay, so here in the canvas, let's rename this to credits text. Good. And again, in the canvas, we have two options to build this button. One of them is kind of an automatic way. If I right click on canvas, choose UI and then button, you're going to have a Unity button already preset here. You can click, you can interact with it. But let's make this differently. Okay, I want you to understand how a button works. A button is not just a button. A button is a collection of generally three things. A background image for the button, then we have the button component itself to interact with the game, and we have the text of this button, which is the label of this button. So how do we build this? Look, we're going to add a new image to this canvas here. So in the canvas, I'm going to right click, choose UI, then image. Okay, I'm going to rename this image to play button, like this. And now here, where it says source image, I'm going to click here, and I'm going to choose the button one. And then set native size, so it's going to have its size like this. Okay. Now we need a label to this button, otherwise it's just an orange square. So inside the button, okay, when we have the play button selected, I'm going to right click, choose UI, then text. This text here, we're going to do something interesting with how the anchoring works. We want the size of this text to be whatever size the button has. So if you increase the size of the button, you want the bounds of this text to follow it. So I'm going to click here in the anchor presets, and here in stretch, I'm going to choose this option here. It's going to stretch completely horizontally and vertically. And if you hold the Alt button or the Option button, you're going to resize it, so it's going to fit everything. Okay, so you see, if you hold Alt or Option, it changes the labels here. I'm basically going to choose it and then click here, and you see that the blue knobs are now matching the bounds here of this image. Okay, good. Once we do this, let's change the font to our custom font. I'm going to rename this to play. Font size, well, 70. Should be easy to read. Then we center it horizontally and vertically, and it seems like we have a complete play button. Okay, I'm going to move it down a little bit. Oops, I'm going to move it here. I think it's good. So you have the play button. However, if you simulate this scene by pressing the play button, of Unity Editor, of course, you notice that you can't interact with this button. Nothing happens when you click, it doesn't fade, it doesn't get darker, lighter. There's no feedback that this is a button. It's because this is still not a button. To add this behavior, you have to select the play button game object. Here we click on add component and we're going to search for button. Okay, so I'm going to click here in button, and just by doing this, if you press play and you click in the play button, okay, so you see it already changes. If you click, it gets darker. Okay, so we are starting to see a button behavior. But what if we want to change scenes? Okay, to do this, we're going to need a little bit of scripting. All right, so this is what we're going to do. In the project folder right here, I'm going to right click and make a new folder. So create folder, and this is going to be named scripts. Okay, good. Inside the scripts folder, I'm going to right click, choose create, then folder again, and then I'm going to name this UI. Okay, and inside this folder, I'm going to right click, choose create, C# script, and this is going to be named scene and then changer. Okay, scene changer. Why I'm doing this? This script is, we want to aim, whenever we're developing games, we want to make some things really easy to reuse. They have to be highly reusable. So when I make a script that's called scene changer, it's clear to everyone that this is basically going to change scenes. Okay, so this is going to be attached to buttons, and we are going to be able to determine what scene you're going to load. Okay, so good. I'm going to double click this script. So MonoDevelop is going to open. We're going to be able to write our code. So let's wait just a little bit for it to be ready. Okay, and whenever it's ready, this script here, okay, this scene changer is basically going to have one method. Okay, I'm going to take all of these, the ones that we have here, away. So no start, no update, not necessary. And I'm going to add here public void change scene, and this is going to receive one parameter. It's going to be string name. Okay, basically in Unity we want to determine what is the name of the scene we want to change to, and this script is going to take care of changing scenes. Now, to change scenes, we need to include a namespace here. Okay, we need to tell this file that we want to have some scripts available for us, some classes to be accessible by us. So I'm going to type using Unity engine.scene management, and here in the change scene method, we're simply going to say scene manager dot load scene, and between parentheses we're going to pass name. Okay, just like that, and you're going to save this script. Once you go back to Unity, you're going to see this little spinning wheel because the code is compiling, it's getting ready for us, and there we go. So you might be asking, okay, how do I tell Unity what scene I want to load? Just wait a little bit. We're going to choose the play button game object, okay, and we want to attach the script that we just made to it. So we select the scene changer and we drag and drop it like this. Okay, so it's going to be attached, or you can just drag and drop it like this in the hierarchy as well. Works the same way. And now if you expand the button component, you're going to see that there's a section that says OnClick. The OnClick is an event that's risen whenever you, of course, click the button. So there is an easy way for us to link this component with this one and call the method that we defined. I'm going to click on this plus button here. Now the OnClick needs a target. The target is going to be the button itself. So we drag the play button and drop it here. Once the button is here, once it's attached here, you notice that this option has been unlocked by us. So we're going to click here. We're going to select scene changer. Notice that it divides by components, by scripts. And here I'm going to select change scene. And notice that we can set something here. Okay, that's because we made this a public method and it has a string parameter. So we can set the value here. Okay, this means that you can reuse this script in as many scenes as you want, in many situations as you want. If you wanted to change scene, you just drag this script here and then you name the scene that you want to load. I'm going to put game here. Okay, that's all. And now to test this out and move on to making the game logic, first of all we need to save this scene, of course. I'm going to File, Save Scene. Here I'm going to name this as Title. Let's save. However, it's in the Assets folder. Let me improve this. Let's right click, Create, then Folder. We're going to have a Scenes folder. And in the Assets folder, I'm going to grab this title scene and drop here in Scenes. Okay, good. We have the title here. Let's make a game scene. Okay, we're going to File, New Scene. Let's make it empty like this. I'm just going to save it again. I'm going to name this Game. And I'm going to drag and drop the game scene here. Okay, Scenes. Now there is one important thing that you have to care about. Whenever you're dealing with scenes, you need to make sure that every scene that you have is added to your build order. Okay, we want to go to File, Build Settings, and you're going to have this Scenes in Build. Right now we are in the title scene. I'm going to click on Add Open Scenes, so the title is going to be added here. Okay, I'm going back to the game scene, and once again I'm going to click on Add Open Scenes. This is going to make sure that all of these scenes can be dynamically loaded. This is essential for any game that you make in Unity. Okay, so we have title and we have game. And now, finally, let's go back to the title scene. I'm going to press the play button. So we have Fruit Ninja, a game by John Doe. We have the play button here. If I click on play, I dynamically load the game window. So with this quick tutorial here, we already know how to easily deal with interfaces and swap different scenes. Okay, you've learned a lot of interesting material, even though you might not have used lots of things, but these are the basics for making interfaces that work on multiple screens, multiple devices. It's going to be great for you to already know all of this knowledge. So once we have this ready, let's move on to developing our actual game. Make sure you save everything. So save scenes, save project, and let's go. Alright, with the title scene ready, we need to go to the game scene and make the game. So we double click the game scene, and we have to make a new canvas. It's going to be exactly like the one in the title, so we should be quick on this. We're going to make a new canvas. So UI canvas, there we go. The screen space is going to be set to camera. We're going to drag this main camera here to render camera. The scale mode is scale with screen size. Reference resolution is 1280 and 920. Okay. Match width or height, we're going to slide all the way to height. Okay, so it's going to match the screen just like the way I told you in the previous lesson. Now we're going to add the background image. So right click on canvas, UI, image. So we have this white square. We click on the source image and choose background. Set native size, and we should be good to go with creating our fruit. Okay, so this should be the first step here. Even though we're not still making the cutting logic, it's good to have something visual first before we move on to anything else. Okay, so let's go to the sprites folder for a moment. Notice that the background is an image with the background. The bomb is the bomb, the button is the button. We have a sword icon here as well. But if you look at fruits, it just looks like this. It's an image with 4 different fruits. We don't want this to be applied directly in the game, okay? You see, this is treated as one object, but this is not how we want it to work, okay? Notice that there is an arrow here in the fruits. If you click here, you're going to see a single image. What we want to do is to tell Unity that we actually want 4 different sprites extracted from this image. In other languages and in other times, if you were programming this a few years ago, it would be kind of difficult to make this work. You would either have to crop this yourself in an image editing software or implement a complex algorithm. In Unity, it's literally trivial to do this. I'm going to select this fruits file, the PNG file, and in the inspector we're going to press Sprite Editor, okay, to have this window here. You might want to resize it a little bit to make it easier to edit, okay? And now what we're going to do here is, with this set here, with this Sprite Editor set here, notice that the outline, when you click on Edit Outline, you can see that Unity can identify that we have all of these 4 different images here. Okay, so this is a little tip for us to understand that it can identify that it has these 4 different images. Now, if you go in the import settings back in the inspector, you're going to see that sprite mode is set to single. However, there is another option, which is the one that we want. There's this multiple option here. If you select multiple and you go to and you apply the changes to this image and you go to the sprite editor, you notice that this slice option is no longer gray. It was before, you couldn't select it, but it's now set as this. And if you choose slice, it's going to say type automatic, pivot center, and well, basically everything is going to be ready for us. We just click on this slice option and we press the slice button. Okay, once we do this, I'm going to apply the changes, close this window, and magically, if you look at the fruits in the project window, you have 4 different fruits set here, which is fantastic. It's exactly what we wanted. We want all of these fruits to be separated like this. Even though we have one image, we have 4 sprites extracted from it. Now, with this here, we should be able to bring just the tomato, for example, to this scene. If I drag and drop it here in the hierarchy, you can see the fruit is here. Okay, so we have this simple fruit. What we want to do now is we want to do a few things actually. We want to make this fruit into something that can be easily spawned in the game. So we want to make a prefab. Also, we want this fruit to behave to physics, and we want this fruit to be cuttable. So there are several different settings that we want to apply to this fruit. So let's do things one by one. I'm going to select the fruits underscore 0 game object and rename this to fruit. Okay, make it something generic, just name it fruit. We already have a sprite renderer, which is responsible for drawing this fruit here. However, if we want physics to be applied, we need to do something else, because if you press play, there's just this image here standing still. So what we're going to do, we're going to press add component, and here we're going to search for rigid body 2D, which is this component here. Okay, if you add it, you don't have to change anything else here basically, but this is something that tells Unity that you want physics to be applied here. If you press play now, you're going to see that the image falls. Okay, that means physics are being applied. Exactly what we want. Okay, perfect. It's behaving correctly. And now, if we want this fruit here, by the way, let me make sure it's fruit. Good. Now, if this fruit here, if you want it to be cuttable, this needs to have a collider. And colliders are essential in most games because you can identify if 2 things are touching each other, if you are clicking on something. It defines an area that determines to the game that physics or collisions are going to happen. With this game object selected, I'm going to collapse these 2 components here, press add component, and you're going to search for box collider 2D, which is this one. Once you click, you're going to see there's this green square around this fruit. Okay, that means it contains that box collider. Also, a few things. If you go to the sprite render, you notice that there are 2 options here. We have sorting layer and we have order in layer. This can be a bit dangerous depending on where you are. Okay, if we set the ordering layer to -1, we no longer see the fruit because the default layer is being used in the user interface and the background is in the position 0. And sometimes if we use this order in layer 0, sometimes we can't see these elements. Okay, depending on how your game spawns things, depending on the order of things, the background might be drawn on top of everything. So to be safe, you should change how this works. If you select the fruit, notice that sorting layer is set to the full. So everything is in this layer right now. However, we want another sorting layer, okay, another layer to draw things just for game elements. So I'm going to click here on add sorting layer. So we're moved to this tags and layers settings. And in sorting layers, I'm going to press this plus button and name this game. Once we do this, let's go back to the fruit. And in sorting layer, we're going to set it to game. Okay, so since the game is below the default layer, this is going to be drawn on top of this. Okay, so we're going to make sure there are going to be no weird drawing problems here. Okay. Also, we want this fruit to be on its own layer. Okay, it's a different layer now. We were talking about sorting layers, but there are layers where we can determine how physics are going to work. How are we going to do this? This game is going to have two cuttable elements. We're going to have fruits and we're going to have bombs, but we don't want both of them to collide with themselves. We want them to move on top of each other. And we don't want to be able to cut any element that we want. Okay, we want to just cut elements that are cuttable. Maybe you want to add other elements in the future, elements that are visual. We want to add particle effects, we want to add animations, but these things you don't want to cut. So it's interesting to come here to click on add layer, and we're going to add another layer here, which is going to be cuttable. Okay, just name it cuttable like this. Now back to the fruit, we're going to select layer and select cuttable. Okay, we're going to keep it like this before we move on to understanding other things. Now, this fruit is a bit useless right now, and why is that? Because if you press play, it just falls. There are no forces being applied upwards. Okay, you don't. Well, they're not thrown upwards for you to cut them. So before we even work on the stored logic, we want these things to be thrown up. Okay, we want to see some action here, we want to see some movement here. So what we are going to do is to make the logic for this fruit to move. So let's go to the scripts folder. We're going to make a new folder here, which is going to be named game, like this. And inside this game folder here, we're going to make a new script. Let's right click, create, choose C# script, and name this move object. Very simple. Okay, we could make this script and call it fruit. However, since this script here is going to be used for fruits and for bombs, remember, make it generic. Okay, divide the behaviors in a good way, in a separate way, so you can easily develop things one by one. Now we're going to go to the fruit, and just so we don't forget, we're going to drag this script and apply it to the fruit. Okay, so it's going to be added as a component here. Now we're going to double click in this move object and open this script here. Now this script is going to need a few different fields. Okay, first of all, and the most important one, we need to define the speeds for moving this object. So the first thing that we want to do is type public float for floating point numbers to have more freedom with the numbers, and we're going to use a few values here. First of all, we need to define the minimum and maximum horizontal speed and the minimum and maximum vertical speed. We can do this in an entire single line. Let's name this minimum x speed, maximum x speed, comma, minimum y speed, and finally maximum y speed. Okay, we're going to use these four values here. Also, this object here is going to last for a determined amount of seconds. It's going to be destroyed after a certain time passes. So I'm going to add here public float lifetime. Okay, it's for how long it's going to live. If you want to make things easier to read, you could add some comments here. So let's name this speed variables, and here I'm going to name this gameplay variables. And there is an even more interesting way to do this. Unity has some attributes that can be used to make things easier to read in the editor and also in the code itself. So instead of naming it like this, we could add an attribute here. So we open and close brackets. I'm going to type header. I'm going to open and close parentheses. And here I'm going to type, let's name this speed variables. And here we can add a header that simply says gameplay. Okay, something very simple like this. It's still easy for us to read. When we deal with the code, we know that these are speed variables and these are gameplay variables. And if you save this and go to Unity and you look at the fruit, you're going to see the public fields that we just typed, and we can see this speed variables header here. Okay. However, you notice that since we've typed several different variables in the same line, the header speed variables is repeating everywhere. So what we can do to fix this is just type public float, put every variable in a single line, okay, in its own line. it works the same way. Okay, there's not going to be a huge difference. It's really up to you how you are going to style your coding. I personally prefer it like this. Okay, we can see things grouped together. We can easily well, basically determine where things are. Okay, so they look grouped like this. Okay, now for the logic, we're not going to use an update method here, because the rigid body that we have added to the fruit is going to take care of the movement. Basically, in the start method, we want to access this rigid body, which is this guy here, and we're going to change the velocity that we have there. So to do this, in the start method, we can just type game object to access the onGame object. Okay, so we are here in the fruit. We are in the move object. However, we want to go to the rigid body. To do this, we're going to move from this script to the entire game object. We're going to search for the rigid body, so we check component by component. Here, we've reached the rigid body, and with the rigid body enhanced, we're going to change its velocity property. Okay, to do this, in the start method, we type game object dot. To search for a component, we use get component. The type of the component that we want, so we put that between the lower than and greater than sign, is going to be rigid body 2D. Remember, you have to use this 2D setting here. Open and close parenthesis, dot velocity, and that is going to be a new vector 2. Since we're dealing with 2D elements, we use vector 2 instead of vector 3. I'm going to open parentheses. I'm going to return a little bit to add some lines, so this is going to be easier for us to read. Okay, so what are we going to do now? This is actually super simple. We now need to use a random number between the minimum and maximum horizontal speeds for the x value, and a random number between the minimum and maximum vertical speeds for the y value. So here, to get a random number, we type random.range. We have to set the minimum value and the maximum value, which is clearly what we have already defined here. Minimum x speed, maximum x speed. These are the two parameters. Then a comma for the y parameter, and now random.range, minimum y speed, and maximum y speed. Okay, so this is basically what we need to make the objects to fly upwards. And finally, we need to implement the lifetime logic. There are different ways to do this, but the easiest of them is to use the destroy method that MonoBehaviors have, okay, that Unity's object has. When you type destroy, you need to pass the game object that you want to destroy, which is going to be itself, okay? The move object is going to destroy its own game object. So we type here game object. This is one signature. It's going to destroy immediately. However, if you type comma, you're going to use a second parameter, an optional parameter, that means you can determine the time, okay, how long this object is going to wait before it destroys itself. And here, I'm going to put lifetime. Okay, that's all we need for these two logics. So let's add some comments. Throw the move object upwards, and here wait and destroy. Okay, we have these comments, so it's easier for us to understand what's going on. Now we save this. Let's go back to Unity and set a few values. Okay, we wait for the code to be ready. Let's collapse a few things, and here in move object, this is what we're going to do. In minimum x speed, we use -3, maximum 3. Minimum y and maximum y, however, they're not going to be symmetrical like the horizontal value. Okay, we do it like this, symmetrical, because the fruit is going to be spawned at a certain range, and it could go to the left or to the right. However, we always want this vertical value to be positive. We always want it to move up. Okay, so we're going to use a different range of numbers here. The minimum is going to be 10, and the maximum is going to be 12. As for the lifetime, 3 seconds is more than enough for this to appear in the scene, go upwards, go down, and then destroy itself if you don't destroy it quick enough. Okay, once we have this, we're going to save this. Let's press the play button, but let's also pay attention in the hierarchy. Okay, I'm going to press play. The fruit should be shot upwards like this, and looking at the hierarchy, after some seconds pass, the fruit destroys itself. Okay, if we press play again, we can see this better. Okay, let's focus on the fruit here. Moves up, disappears, destroys itself. So the behavior is working exactly as we expected. Okay, let me just move this fruit here. And now that we have this game object built with all the settings added here, with the sprite changed, everything working here, we want to transform this fruit into a prefab because this game is dynamic. Whenever you're making arcade games, you have to instantiate things all the time. You have to add copies all the time. So you don't start the game by adding hundreds of fruits here. You just make a logic that is going to put fruits in the scene as the game moves on. Okay, so let's make this into a prefab, something that can be copied and pasted dynamically by our code. We go to the project window, so project folder, right click, create folder. This is going to be prefabs. I'm going to open this, and to transform this fruit into a prefab, I'm going to drag and drop it here. And our fruit has been saved. We can even delete this one from the scene if we want, which we do, so we delete it. I'm going to save the scene, and now we are left with no game because I have removed the fruit, but we do this because we're going to make a fruit spawner. Okay, something that is going to add fruits all the time in the game. Let's do this in the next video. Alright, so let's remember one thing. This game is going to have fruits and it's going to have bombs. The fruits are going to increase your score. So you start with 0 points, and as you destroy fruits you have 100 to 100, 1000 points. But you also have a certain amount of lives. So for example, you start with 3 lives. If you get a bomb, you're going to have 2 lives, 1 life, until it's game over. So the thing is, the fruits and the bombs are going to be dynamically added to this game. Okay, we're not going to have a fixed amount. It's going to be infinite. It's going to have to appear to spawn all the time. So when we make a spawner, we want to make sure this spawner can be reused to set fruits and to set bombs. Okay, so let's go to the hierarchy window, right click, create empty, and rename this game object to fruit spawner. This one is going to use it's going to spawn basically fruits. Okay, but here in the scripts folder, we're going to the game folder, right click, choose create, C# script, and this is going to be named spawner, just like that. Okay, or you could name this object spawner. Okay, let's keep it like this. We wait for the code to be ready. With the fruit spawner selected, I'm going to drag and drop it here. Okay, and now we're able to edit this object spawner, this generic spawner that is basically going to add multiple things to our game. Okay, so first of all, we need a reference to the object that we want to spawn. I'm going to add public game object, and whenever we spawn something, we're going to spawn a prefab. Okay, so I'm going to add it like this: public game object prefab. Now we need a few variables here, so let me add a header here, and I'm basically going to name this target, the thing that is going to be spawned. Now I'm going to add another header here, and this is going to be, let me see, gameplay. It's the tuning variables that we're going to define. I'm going to add here a public float, and then interval is the time that we're going to wait between all the time that we spawn. We're also going to add a public float minimum x. Okay, this is the minimum value to the left that is going to be used so we spawn objects. Public float maximum x. Okay, so one for the left and another one for the right. And public float y. Okay, the vertical position where the objects are going to be spawned, just like that. We're going to add another header here, and this is going to be named visuals. And why is that? Okay, whenever we spawn a fruit, we have 4 different sprites that can be used, and this object spawner can be the one responsible for selecting any sprite that you want. Okay, because remember, you have a tomato, but you also have an orange, pear, and a pineapple to use. So here in visuals, I'm going to type public, and then sprite. Since there can be multiple sprites, we're going to add brackets here. So this is going to be a sprite array, and this is going to be sprites. Okay, so Now that we have these things, we can save this and go straight to Unity to set these values. If you want it, it's interesting to first define the values and then set them here in the editor, just so you don't forget. Okay. So as for the prefab, I'm going to drag the fruit and drop it here. Okay. Now we have the reference for the fruit. Now we have to set the values for this spawner. Okay, something that's going to be interesting. Let's use 2 here. Let's use -2.5 for x for the minimum value, 2.5 for the maximum one. In the vertical position, let's use -5.5. And as for the sprites, remember we have 4 different options. So I'm going to change the size of this to 4 and hit enter. And we're going to have these options. So to put the sprites here, we just go to the sprites folder, which is this one. And I'm going to drag, remember, you might be seeing it like this, but if you expand this arrow, you're going to see all the fruits. And I'm going to drag one by one and put in these slots. So this one here, fruits 0, fruits 1, fruits 2, and finally, fruits 3. Okay, so everything has been set here, everything has been attached, so these things can be used by us in the code. So let's go straight to the code. The logic for the object spawner is going to be like this. We're going to have a method that is going to be repeated after interval seconds pass, and it's going to basically happen forever. There are multiple ways to work on this logic, but Unity has an interesting way to make this work. First of all, I'm going to not use an update method. I'm going to make a private because nobody needs to know what this method is, void, and then spawn, open and close parentheses, open and close curly braces. How is this spawn logic going to work? First of all, we need to instantiate the prefab that we have. I'm going to type game object instance is going to be, and then I'm going to call the instantiate method. And here, I'm basically going to pass the prefab as a parameter. Remember, this is a prefab, but you have to instantiate it in the scene so you can see its copy in the hierarchy and in the scene itself. Okay? And now we have to set the position of this. I'm going to type instance.transform.position is going to be a new vector 2. We have to set the values for x and for y. The x one is easy, we already know how to do this. Random.range, minimum x as the first parameter, maximum x as the second one, and the vertical value is even easier, it's just y. Okay, just the vertical value that we've passed before. Okay, and once we do this, well, this should already spawn the object for us. Okay, so let's add here, add the object instance, okay, or just instantiate and position the object as a comment. And now we want to change the sprite of it, so select a sprite for it, for the object. So how do we do this? We have 4 different sprites in the case of the fruit. It could be 1,000 sprites, it could be 1, 2, 3 sprites. The thing is, we want to select a random one. Okay, we just want to get one random sprite and then use it in the sprite render of this object that we're dealing with. So here we're going to type sprite, and then let's name this, and let me see, random sprite. Let's use this name here. Okay, and to select the sprite, I'm going to type sprites. Since this is an array, we can access whatever sprite we want by passing an index here. It could be 0, 1, 2, 3, 4, 5, it could be any name, any number here. But since we don't know the size of this array, we need to get a random value between 0 and the size of this array. I'm going to type random.range, in between parentheses 0 as the first parameter, and sprites.length as the second one. Now there's something interesting to talk about here. Imagine we have this array here with the values cat, dog, and bird, for example. Okay, this is just a little example that I'm going to show you. And there we go. Okay, we have this array with these 3 elements here, cat, dog, and bird. Now, the size of this array is 3. So length is 3 in this case here. Okay. However, the valid indexes are 0, 1, and 2. So you might be asking yourself, okay, we have 4 sprites in this scene, and the parameters that I'm passing here are basically 0 and 4. So what if we have the number 4 in this random range? So here's the thing here. Sprites.length it returns an integer number. There's no floating point value here. 0 is also an integer number. So when we use random.range with two integer numbers, the last value that we pass is not used. Okay. So for example, let me add another animal here. Alligator. Okay, so length is 4, indexes are 0, 1, 2, and 3. Okay, so the length of this is 4, but if we use random.range 0 as the first parameter and 4, the valid numbers that can be outside of this method call are 0, 1, 2, and 3. 4 is not used. It's exclusive, okay, because we are using integer numbers. So this is an easy code, is a quick code for us to get a random element in an array. We just select the array and get a random number between 0 and the size of this array. Okay, so if I use here random.range 0 and sprite's length, I'm going to have 0, 1, 2, or 3, never 4. Okay, so we're going to get the random sprite, and now that we have this sprite enhanced, we're basically going to get the instance that we just added. We're going to find its sprite renderer component, so get component of type sprite render, open and close parenthesis, then dot sprite to access the sprite property, and it's going to be equal to random sprite. Okay, so select a random sprite. Okay, set a random sprite. So this is basically what we need for this object spawner. But the thing is, we have to find the spawn method, but how do we call it repeated times? Here we can just call this amazing method called invoke repeating. Okay, you're going to call a method repeated times. So the method needs to be called as a string here. I'm going to name it spawn. This is the first parameter, is the string. The second value here is going to be the time to wait before it is going to spawn. So this is going to be interval. And the third value is the repeat rate, how many seconds we have to wait before it's going to be called again. This is interval again. Okay, this is the initial waiting time, the initial delay, and then the repeated time. Okay, how many seconds is going to wait before it's going to repeat again. Okay, so we are going to save. We go back to Unity, wait for the code to be compiled, and after we do this, if we press the play button, we wait 3 seconds, we see one fruit. 3 more seconds, another one, and they're going to keep being added like this. Okay, if you look at the scene window, you can see things being spawned at runtime. We are spawning it in the position -5.5, and the fruits are basically going to be spawned. You notice in one interesting setting here that 2 fruits have collided. Okay, depending on how you make this, that might be a desirable result. It's really up to you, but in general this is not good because a fruit has been added but it disappeared instantly like this. It's a bit unfair to the player, let's be honest. To change this, okay, we're going to make use of the layer that we have set in the fruit, this cuttable layer. We're going to edit here, project settings and physics 2D. Remember not to confuse with physics. We are dealing with a two-dimensional game, so we go to physics 2D. Okay? So now that we have this physics 2D here, if you look down, there's a layer collision matrix. This is basically going to determine which pairs of layers are able to collide with each other. Okay? We don't want elements in the cuttable layer to collide with other elements in the cuttable layer. So we're going to look here, cuttable, in this horizontal line, and we're going to search for cuttable in the vertical line. So this square here in this matrix is the collision between cuttable and cuttable. I'm going to basically unmark this checkbox. Okay, let's go to File and hit Save Project. Okay, back here. If we press play again, then these fruits they shouldn't collide with themselves anymore. Okay, they might go one right inside the other, but they're going to basically overlap. Okay, no physical collisions. They're not going to collide like they are blocks or boxes. They're going to go right inside the other. Okay, we shouldn't wait too long for this to happen, but basically you can trust this physics system like you just saw. Okay, they're not going to collide themselves. So perfect, we have a fruit spawner, but we should also have bombs. You're going to see how easy it's going to be to implement this because of the way we've developed things. Okay, let's do this in the next lesson. Remember, save your scene, save your project, and let's move on. Okay, so let's make a bomb. You're going to see how easy it's going to be making a bomb. Okay, so in the prefabs folder, we have this fruit. If you want to duplicate this prefab, you can just hit Ctrl D or Command D. And once you do this, you're going to have another fruit. But I'm going to rename this fruit one here to bomb. Okay, so this is set to bomb. With this prefab selected, I'm going to the inspector, I'm going to the sprite render, and I'm going to change this sprite here from fruits 0 to bomb, which is here. Okay, and if you do this, it's going to be updated here. You can even drag and drop to see how it's looking like. Okay, it's looking like this. It's still a bomb, it's still in the game layer, it's still cuttable, which should be. Okay, it's exactly what we want. And to add bombs to this game, we're going to duplicate this spawner. So we right click, choose duplicate. I'm going to rename this fruit spawner to bomb spawner. The prefab right now is fruit, but I'm going to replace this to bomb. And we have 4 different sprites, but we just have one bomb sprite. So let's change the size of this to 1, hit enter, and change the element to the bomb sprite as well. Okay, and just by doing this, if we press play, let's see how it looks. Okay, so we press play, we see a fruit and a bomb. Fruits and bombs, fruits and bombs. They keep appearing together here. So because you organize things, because you made scripts generic, easy to use, easy to configure, things can be done super quickly like this. It's fantastic when you do it like this. Okay, it's just very, very simple. And you might want to make a few changes in the spawner. You don't want bombs to appear as frequently as fruits, so you might want to change this interval to 5, for example. Okay, it's going to be a different rate. And if you press play again, if you look at the hierarchy, you notice that the elements that are added, they are added as clones in the hierarchy, like this: fruit, bomb, fruit. I personally don't like this very much because it crowds the hierarchy too much, and there is a better way to add these things. So what we want to do is very simple. To make sure the elements that we add are going to be inside their spawners, inside the fruit spawner or inside the bomb spawner, we're going to the object spawner code. And whenever we spawn anything like this one here, whenever we spawn this instance, down here I'm going to type instance.transform.setParent. So we're going to determine the parent of this instance, and the parent is going to be the spawner itself. To reference the transform of this object spawner here, we simply type transform. Okay, that's all we need. We're going to save the script again. Let's go back to Unity. We're going to wait for the code to be ready, and if we press the play button now, we're going to see it like this. Okay, and whenever things are spawned, you're just going to see this arrow here. Okay, because there's something spawned in the hierarchy. They still have their own lifetimes. They still destroy themselves. They have these speeds. It's still the same fruit, the same bomb. However, they're added in the correct place to keep things organized. Okay, so that's all we need to spawn elements. We have all the knowledge we need to do this. And now that we are done with creating fruits and creating bombs, we should move on to the interesting thing. We should move on to the actual gameplay. We're now going to make the cutting logic. Let's do this in the next video after we save our scene and we save our project. Okay, some Fruit Ninja games, they use some complex logics for the cutting effect. You see some cuts that do some curves, they have some interesting particle effects, but we want things to be simple but still have an interesting effect, but still be able to have that feedback for the player that they have swiped the screen, that they are going to cut something. So we want to make a cut prefab. This game object is basically going to draw a line and then make a collider to follow this line. So we're able to detect collisions between this line and the bombs and the fruits. So let's make this game object first. Here in the hierarchy, we're going to right click, we're going to choose create empty to make an empty game object, and we're going to rename this to cut. Okay, it's a very simple object. And this is going to need 2 components. We're going to click Add Component and search for Line Render, which is this one here. And I'm going to click on Add Component and search for Edge Collider 2D, which is this one here. Okay, so you have both of these. Now, how these lines work? Okay, you see there are several properties here. We have almost 20 different elements to deal with. But there's only one thing, there's only actually two things that you have to worry about. First of all, the color. I'm going to use red for this one. So we click on this white rectangle. And here I'm going to click on this other rectangle and choose red for this color. I'm going to click on this knob here and change it to red as well. So that means our line is going to be red. We also changed the width of this line. I like to use 0.3 for the width. But we still can't see this line. Why is that? The line has positions that you can set. Okay, you can set two different positions. It's basically the beginning and the end of the line. And if you increase the position X by a little bit and the Y by a little bit, you can see the line being dynamically rendered and changing its position. You notice that even though we've set the color of this line render to be red, it's pink. The interesting thing is, if you change this to whatever value you want, if you change this to blue, if you change to green, if you change back to red, it's still going to be pink. This is a rendering problem. This is happening because if you go to the materials folder, the materials field here, we have one material but it's set to none. We want to use the default material for sprites in Unity. Basically, we're going to click on this circle and we're going to search for sprite. Okay, so let's look a little bit. There we go, sprites default. If you select this, it's now red. Okay, so it's going to respect whatever color you add here. Okay, if you want to make it look like a rainbow, you can even do that. Okay, you just change the color to whatever you want. Let's use plain red here. And this is the moment that you can use to change the height, the width of this line as well. Okay, it's not good to have a super thick line. Make sure it's going to be simple like this, 0.15 or 0.3. Okay, but the thing is, these values here for the positions of the line are not going to be set here. They need to be set dynamically because we're going to identify where the player is clicking so we can spawn these cut prefabs. So it's not going to make a difference, but I'm going to change the position on element 1 to 0, 0, 0. Let's leave it like this. Okay. And as for the edge collider, if you zoom in a lot, you're going to see there's a super small line, super small green line. This is just a line. There is no height applied here. It's like it works only as a line. And this is going to be used for collisions, okay, which we're going to see later. Okay. And now that we have this set, we want to select this cut game object and transform it into a prefab. Okay, we just set its visual settings, but we're going to make another script work with it. I'm going to drag this cut game object, drop here in the prefabs folder, and after this is done, we can go ahead and delete this cut game object. Okay, let's save the scene just so we don't forget to do this from time to time. And now we want to make the sword. So the sword is not going to be an actual sword. It's not going to be how we use the sword graphic, okay, to make it swipe in the screen, but it's going to be an abstract thing that is going to identify where we are clicking in the screen. Okay, so when we click and we drag, we're going to spawn the cut element with the proper settings. So let's make it. In the hierarchy, we right click, choose create empty. We rename this game object to sword, and of course it needs its own script. So we're going to the game folder here. We're going to create a new script. We're going to name it sword. We hit enter, wait a little bit, and once this is done, we select the sword game object and we apply the script here, just so we don't forget. So it's going to be executed. Okay. Now we're going to double click on this sword and work with its script. We're going to need a few things in this sword. Okay, so I'm going to add a header here, and let's simply name this gameplay. There's not going to be a lot of things here. It's actually super simple. I'm going to add a public game object cut prefab. Okay, and I'm going to add a public float cut lifetime. This is how many seconds, how many milliseconds actually, the cut prefab is going to be alive before it destroys itself. Also, we're going to need two more variables here. We're going to add a private bow dragging. This is going to hold whether we are dragging the mouse or not. And I'm also going to add a private vector2, and this is going to be swipe start. Okay, whenever we click, it doesn't matter where we click on the screen, that position that we click needs to be saved. Okay, we need to do it like this because we don't know where we are going to release the mouse, okay, and when we're going to release the mouse. So the coordinates that we click need to be saved, because when we release the mouse, then we're going to show the cut effect that's going to be spawned. Okay, so alright, let's move on. We're not going to use the start method, so let's take it off. And in the update method, we're going to do a little game with some variables here. Let's make an if-else block. So if, open and close parenthesis, open and close curly braces, else, and the same thing, else if, open and close parenthesis, open and close curly braces. This first pair of parentheses here is basically to check if we are touching the screen or clicking the screen. So I'm going to type input.getMouseButton down. Okay, this method here is different from getMouseButton. Okay, why is that? GetMouseButton is going to return true every time you keep the mouse held down. So if you click, it's going to return true, but if you keep holding the mouse, every frame that passes is still going to return true. That's not what we want. We just want this to return true in the exact moment, in the exact frame we click with the mouse. So that's why we use GetMouseButton down. I'm going to use 0 here for the left mouse button, and you might be worried, hey, is this game going to work on mobile devices? And the answer is yes. This is converted to touching when you use the mouse button logic here. Okay, it's still going to interpret like you were clicking in your game. Okay, so if we're clicking, it means we started dragging. So dragging is going to be set to true. Okay, and also swipe start, which is going to be the place where we clicked. Then here we need to determine where we clicked, but there's going to be a catch here. Okay, let's type this input.mousePosition. Okay, this, if you hover the mouse in this mouse position here, it's going to say the current mouse position in pixel coordinates. This is very important. Okay, the pixel coordinates, they're going to range between 0 and 1280 and 0 and 920, okay, which are the values that we use for the canvas. But this is not the type of coordinates that we want. Okay, these are screen coordinates, but we want world coordinates. We want the coordinates in the Unity space. Okay, for example, let me select the fruit spawner. The fruit spawner right now is in the position 0, 0. If I move it to this position, it's now on -6, 0. But this is completely different in screen coordinates if you click on the screen. Okay, these coordinates, they don't match. So you need to convert this, and to do this conversion you need the camera. There is a super easy way to access the camera. You can just type camera.main, so you get the first enabled camera with the main camera tag, which it already is. Okay, then dot, and we're going to call a method called screen2worldPoint, and we pass input.mousePosition as a parameter. So it's going to make the conversion, and this swipe start is going to be determined in world coordinates. So we can easily use this to change how our line render is going to work. Okay, good. Now here in the else if, we're basically going to type input.getMouseButton up, and we're going to pass 0 as a parameter, and we also need to check if we are dragging. Okay, so and dragging equals to true, or just if dragging. Okay, like this. So if this happens, we need to create the cut prefab. This is when we're going to spawn the prefab that we made a few seconds back, okay, a few minutes back, and change its size correctly. Okay, so we're going to call a separate method for this, just so everything is not going to be crowded here. So let's make this a spawn cut. Okay. Now down here, private void spawn cut. Let's open and close parentheses, curly braces, and let's go. Now, when this happens, we're going to set dragging to be false, okay? Because we're no longer dragging, we're going to spawn the cut prefab, okay? And or even better, you could even move this line here to be before spawn cut, because the spawn cut method doesn't need to know what dragging is. It's important for you to make this reflection, to ask yourself from time to time if a certain method, if a certain class needs to know about something else. Okay, spawn cut doesn't need to know anything about dragging Boolean values, so we can move it back here. Okay, it even matches how we are coding these two if blocks. Okay. Now here, what we're going to do, we already have swipe start, but we need swipe end. The logic is going to be exactly the same, so I'm going to copy this entire line of swipe start just to save some time, paste it here, but I'm going to name this vector2 swipe end. Okay, so we have vector2 swipe start and a vector2 swipe end. Okay, now that we have this, we're going to spawn the cut prefab. So I'm going to type game object cut instance, and this is going to be instantiate. So I'm going to instantiate the cut prefab, and I'm already going to set its position. Okay, so we can use another signature of this instantiate method. Okay, that takes the prefab, the thing that we want to instantiate, the initial position, which is going to be swipe start, and the rotation. We actually have to set this rotation. We're not going to change it, but it's necessary for this signature. It's going to use quaternion. You don't need to understand what this is for this specific lesson, but let's name it quaternion.identity. It's basically the simplest rotation. It's like there is no rotation at all. Okay, so this is enough for instantiating the cut object. Okay. Now, what we have to do is to set the position of the line render. Remember when we were dealing with the line render and we were able to change how it looks, okay, where it starts and where it ends. So we need to do it like this. Cut instance dot get component of type line render. Let's open and close parentheses. Dot set position. Okay, remember this line is going to have two positions. Okay, we have the position 0, which is the first one, and position 1, thus drawing a line. So we're going to first set the position of the point in the index 0, and now the position is going to be swipe start. We do almost the same thing again. Cut instance dot get component of type line render dot set position again, but this time the index is going to be 1 and the position is going to be the swipe end position. Okay, this is what we need for drawing the line render correctly. Okay, but this is not everything we need. Okay, besides changing how the line is going to be rendered, we also need to change how the collider is going to work. Okay, to change the our collider. So we need to select and set what are the collider points. I'm going to type here vector2. This is an array, open and close brackets. Collider points equals to a new vector2 with size 2. We're going to use exactly 2 points. Okay, so we can instantiate this vector with size 2 set here. Now, the first point is going to be a bit odd for you. I'm going to type collider points 0 is going to be vector2 dot 0, which is the same thing as typing new vector2 0 0. Okay, same thing. So why are we doing this? We're doing this because this collision here, okay, this collider, the initial position is going to be relative to where the cut instance has been added. Okay, so it starts whatever it is. That's why we set its position to be 0. It's different from the line render. Okay, it doesn't matter where the game object is. We still need to set swipe start and swipe end, but for the collider it's different. It's a relative position system. Okay, so we go for collider points in the position 1 now, and this is going to be swipe end minus swipe start. Then again, this should be a bit odd for you, but when we do this, we're basically going to get, imagine we have 2 points in the screen, and we want to get a vector. It's kind of, we're getting an arrow from one point to the other. Okay, this is like getting the distance between swipe end and swipe start. When we get this distance and we set it here, then it's going to behave correctly, and you're going to see that live in the game. Okay, you're going to see how this is going to work. And now that we have built this array, we can change our edge collider. So we're going to type cut instance dot get component of type edge collider 2D dot points, and that is going to equal to collider points. Okay, and finally, after we do all of this, we're going to add the lifetime for this cut object. So we're going to type destroy. First parameter is cut instance, and the second one is the cut lifetime. Okay, so we did 4 different things here. First of all, we've identified where the swipe ended. We have spawned the cut object. We have adjusted the edge collider. And finally, we have scheduled the destruction of the cut object. Okay, that's basically what we need, these 4 things. Okay, it's interesting when you group the lines like this. Don't just put all of the lines together. Add some breaking points, some indentation, add some comments, so it's super easy for us to understand what is happening here. Okay, so I'm going to save. Let's go to Unity, wait for the code to be ready. We're going to look at the sword, and for the lifetime, let's use 0.3. And the cut prefab is, of course, this cut prefab. Okay, let's give this a try. We're going to press the play button, and if I click and release the mouse, we see a line. Okay, so we can easily cut things now. They are not cutting yet because we are they're colliding. They're doing actual physical collisions with the object that we add here. But we're going to work on this logic. You don't have to worry too much about this right now. Okay, but the interesting thing is when you have a cut object here. Let me get position and change this to 10 on 1. So notice that if I move this cut line around, okay, I'm going to play the game. We have this cut game object here. Even though I'm changing its position on X and Y, the line is in the same place. So the thing is, we need to be really careful about how the positioning works here. The position that we put for the lines is global, but for the edge collider, this is local. It's relative to where we currently are. That's why we do this different logic for the line render and the edge collider. Now that this is complete, we need to work for the logic so the sword, when it draws these cuts are able to destroy the fruits and the bombs. They're going to have different effects later, I mean adding points or taking off lives, but we're going to work on this soon enough. Okay, let's work on this in the next video. Remember to save the scene. In order for cuts to behave in an interesting way, it's interesting for us to select the cut prefab, which is here, and we want to apply a tag for it. This cut prefab here, if you remember, we don't have any scripts attached here, so it's not interesting to make a script just so we identify collisions with it. We can simply add a tag here. I'm going to click on this tag field, select add tag, and in this list we press the plus button and name this cut. And again, we save. Okay, so we select the cut prefab again, and we set its tag to be cut. You're going to understand why we're doing this soon. Now, how are we able to destroy fruits and bombs? We are going to need a script so we can work on this logic. I'm going to the scripts folder, then game, and here we're going to right click, choose create, C# script, and we're going to make one nice cuttable object script. Okay, so this script is going to be used for both fruits and bombs. I'm going to select the bomb prefab and apply this cuttable object script to it. Okay, let me select bomb here, then game. Okay, good. Let me collapse this, and I'm going to drag and drop cuttable object here to the bomb, and the same thing for the fruit. Select the fruit, game, cuttable object. Okay, good. The script has been applied to both the bomb and the fruit. But how is this script going to work? To identify a collision between these elements and the line render and actually the edge collider that we have, I'm going to type here void on collision enter 2D. It needs to be exactly this name, and we need exactly one parameter of type collision 2D. The name of this parameter could be anything you want, but I'm going to name this collision. Okay. Now, depending on how you make your game in the future, there might be other things to collide with, so it's important for us to identify if we are colliding with the cut object. To do this, we're going to type if collision.gameObject.tag, so we get the string set in the tag field, and I'm going to compare it with the text cut. It's the tag that we have just defined, so you need to make sure you use this exact same name. And if this happens, well, we're going to destroy this cuttable object. So we're going to pass destroy, and we set gameObject as the parameter. Okay, so basically identify if the object is being cut. Okay, save the script, we go back to Unity, and let's give this a try. Okay, so wait a little bit for everything to be ready. We're now going to press play, and once we do this, we're going to see a fruit. If we are able to cut it, then the fruit disappears. Okay, the bomb disappears, the fruit disappears, so the same script is being used to destroy two cuttable objects, any cuttable object that we make. Okay, so this one, we're able to cut things. However, fruits and bombs are going to behave differently. Fruits are going to add score points for you, and bombs are going to remove lives from you. So we're going to deal with a little bit more interface now. Okay, so we're going to start with score points in the next video. So for showing the score, we're going to have a score text field here. Okay, we're going to do this in one way so you can see it completely working. Then we're going to adjust this later, but let's do it the simple way. I'm going to open the canvas and I'm going to right click, choose UI, and then text. Okay, with this text set here, I'm going to select this tool for resizing. I'm going to increase its size like this. I'm going to anchor this in the top left and then move it here, should be good. And in text, I'm going to set this to score 0 and change the font size to, let me set it to 60. The font is going to be Jojo Maru, and the color is going to be white, so it's easy to see, easy to spot. Okay, so we have here score 0, good. Now, how do we change this score value here? We need to find a way to change this. So now we're going to make a new script here in the game folder. Since this is going to be UI as well, I'm going to make this different. I'm going to rename this UI folder that we have here to title. Okay, just so we don't mix things. Okay, so title is going to have everything related to the title scene, and game everything related to the game scene. We can later change this if we want. Here we can right click, choose create, then folder, and name this UI, only for interface elements. And here, right click, create C# script, and I'm going to name this score text. Okay, could be something like this, or just score. Could be any name we want. So we're going to select this text here. I'm also going to rename it to score text. And now I'm going to drag this and drop here. Okay, good. So how is this score text going to work? Okay. Also, before we do this, let's make sure it's going to be aligned here. Okay, left and top. Right? Good. So how is this score text going to work? Things are going to be able to access this class here, and they're going to be able to change the value that is set here. They're going to be able to change the score. So there are different ways to do this. One way that we're going to do this is to define a private variable and a public property. When you have a property, you're going to set getters and setters, so you can change this value or retrieve this value from other places. Let's do things one by one. So I'm going to type here private int score, and I'm going to set this to 0, and I'm going to type public int score with an uppercase S. And imagine we're making a method here. We need to open and close curly braces. Now this needs to have a getter and a setter. When we get the score, when we just try to access this property, we're basically going to return score, the private variable that's set here. Okay. Now when we try to set the score, this is going to be a bit different. When we set the private variable score is going to be set to the value that we're passing to this property. You're going to understand soon enough why we are doing this, okay? Now, the magic here is whenever we set the score, we don't just change this variable here. We also have to update the score text that we have here. So remember, this is like defining a method. So here I'm going to type get component of type text, open and close parenthesis, dot text is going to be a certain string. This string is going to be score, colon, space, okay, plus score, okay, the score that we have set. But the thing is, text is set as red here. Unity can't find this class. It cannot find this because we need to include a namespace to be able to deal with interface through code. So here we type using Unity engine.ui for user interface. So we're able to change the text. And now basically what we do here is we don't need the update method, and in start, just to make sure, we set score with an uppercase S is going to be 0. Okay, so when we do this, we're forcing the value to be 0, and we're forcing the score text to be updated like this. So the score text, this class, is going to be super simple, and everyone that deal with the score text class is basically going to get this value, this property here, and increase it by a certain amount of points. Okay, that's basically what we have to do. So I'm going to save this score text here, go back to Unity, we wait for this to be compiled just to make sure it's going to work. Okay, no public fields, no need to change anything else here. But now we move back to our cuttable object. Okay, so first of all, there are two different objects. We have fruits and we have bombs, but there's a more generic way to think about this, so you can save lines of code and save having to replicate your code and duplicate it in several places. We just have two objects. We have non-harmful objects and we have harmful objects. So here we can just type public bool harmful. By default, when you set a variable like this, it's going to be false, okay? But in Unity, we can change that checkbox to be true or false if we want, okay? But still, what we're going to check here is if harmful equals to false, or if basically not harmful, okay? It's easier to read when it's a simple name for a Boolean variable. If it's not harmful, then we need to update that score. So in Unity, we need to find this score text game object. We need to get the score text script and then change the score. To do this, here we're going to type game object dot find. Okay, so we're going to search the entire scene for a certain name. I'm going to find the game object with the name score text like this. Good. When we get this game object, we also need to access its transform and then type get component. And what component we need? The script that we just defined, score text. Once we do this, we type dot. We can access the score property we just set. You can even see it here, public int score. It has a getter and a setter. But we're just going to get score plus equals 10. Okay, we're going to add 10 points whenever we destroy an object that is not harmful. Okay. By the way, let's also add here else, open and close curly braces, and we're going to do this logic later. But we can already save this. We can go to Unity, wait for the code to be ready, and let's give it a try. Okay. If you go to the prefabs folder and you select the fruit, you're going to see that harmful is unchecked. But if you go to the bomb, you need to check this harmful checkbox. Okay, so it doesn't add any points now. Now let's press play. Okay, so we have score 0, we have a fruit here. Let's just let this fruit go. This one, if I destroy it, we get 10 points, 20, 30, and if we destroy a bomb, we get anything because the bomb is harmful. Okay, so very simple logic here, very simple searching. Just add a property to the score text and we're able to update this text very quickly. Just make sure this text is wide enough to show different values here. This is something very important for you to care about, because if you have a short text field, let's say it's imagine the text field was like this, and you're destroying fruit. So we have 70, 80, we have 90, and then we have 100. So the number doesn't fit and we can't see the number anymore. This is a super common mistake. Make sure your interface is wide enough to support multiple different values. Okay? So if I press play, it restores the previous settings, by the way. Let me just make it like this. And they should be good. Okay, let's save the scene. And now that we have this, we're going to work on an interesting logic. We're going to work now on showing the amount of lives the player has. Let's do this in the next video. Okay, now lives are going to behave a little bit differently. Where the score is a text, so we can just change the string that we have here, lives are going to be better. Okay, they're going to be images. So first of all, we need an image for the live. Okay, so in the canvas, we're going to right click, choose UI, and then image, and we're going to change the sprite of this image. So in source image, we click on this circle. We're going to find the sword, which is here. Good. I'm going to click on set native size just to make sure. Okay, it's going to be a bit small, but that's how it's intended to be. We're going to change this image to live. Okay, it could be sword, but since we're working with the live, let's name it live. And we're going to transform this into prefabs. So I'm going to drag it from here, drop it to the prefabs folder, and I'm going to delete the live from here. Okay, so you might be asking yourself, hey, why did you delete the live here? Aren't we going to add in the top right? We are going to do this, but it's going to be dynamic. Okay, it's not going to be exactly we're not going to already start by adding it here, because depending on how you want to make your game, maybe you wanted to, well, the player to start with 5 lives or 3 lives or just 1 life. It's really up to you. So this should be dynamic. Now we need to make another object here. Okay, so I'm going to the canvas, and here we're going to right click, choose create empty, and rename this game object to player lives. Okay, so now that we have this player lives game object, okay, now that we have this, I'm going to move it to the top right. Okay, let me move it like this just so it's easier for us to drag. Okay, I'm going to put it here, and I'm going to click in the anchor and choose top right just so it's going to be here. Okay, and now we're going to need a few components in this. I'm going to click on add component, and we need a grid layout group. Okay, not the edge collider, of course. Add component, grid layout group, which is this one here. And what this does is whenever you add new things, they're going to be aligned correctly. Okay, they're going to be automatically resizing and repositioned, so you don't have to worry about setting the position of anything. Okay, the cell size can remain like this, 100 and 100. The spacing, we're going to use 30 pixels of spacing, okay, between each image. And start corner can be up left, axis horizontal. The child alignment, however, we're going to use upper right, so they're going to spawn from this place to the left. And the constraint here is going to be fixed row count. We just want 1 row. So we select this and change constraint count to 1. Okay, so this is the player lives element that we just made. Let me just move it here. Okay, it's a nicer position. Okay, and now that we do this, we need a script for this. Okay, so in the UI, I'm going to right click, choose create, C# script, and then let's name this a live counter. Okay, by the way, let's rename this player lives to live counter. Okay, just so it matches the same name, live counter. I'm going to drag and drop this live counter script here, and you're going to start working on its logic. Okay, we're going to need a few things in this script. So let's start. I'm going to add a header here. Header. I'm going to add a gameplay name, and here I'm going to add a private int, and this is going to be, let me think, number of lives. Okay, should be good, this name. Okay, it's how many lives the player is going to be. Okay, now we're going to add here another header, visuals, and I'm going to name this, actually this is public, by the way. This is going to be public game object live prefab. It's the little sword that we just made, and we're also going to add more fields here. I'm going to add a public game object, and I'm going to name this, and you're going to understand why later, score text, and I'm going to add a public game object, and I'm going to name this game over group. We're not going to use this right now, but it's still part of the process here of telling that the game is over. This is going to be improved soon, okay? And finally, we're going to need a private list of game object and then lives. So what's going on here? Why we're using list instead of an array? This list is going to be dynamic, so we're going to add multiple lives, but as the player is hurt, okay, as we lose lives, then we're going to remove the lives that we have here, okay? So now that we have this, in the start method, we're going to build the lives list. We're going to add images and add their references to this so we don't lose track of where they are. So in the start method, we type lives is going to be a new list of type game object, and we open and close parentheses. Now we need to use a loop here to add new images. So I'm going to add for and a classical loop, int I equals to 0 while I is less than the number of lives, and in the end I plus plus. This is just an iterator for this loop. It's going to repeat this amount of times. So game object live instance is going to be instantiate, and then we pass live prefab as a parameter. If you want this to already have a parent, you can type here transform. Okay, so it's going to be already under the live counter transform, which is exactly what we want. So this is going to be enough to instantiate it, and also it needs to be under this parent, by the way, so it's going to be inside the layout group. Okay, and now that we have this live instance, we need to save its reference in the lives list. So lives dot add, and we add live instance here. Okay, lives. Okay, so this should be enough for saving all the references. But now we need to make a new method here for whenever the player is hurt, for whenever we lose a life. So I'm going to put here a public void lose life. This is the method that we're going to do. First of all, when we call this, we're going to type let me see here, it's number of lives minus minus. So this is the same thing as typing number of lives minus equals 1. We're going to decrease 1 life point. So number of lives minus minus. Okay, now what we want to do is to remove the last life that has been added and it's still in our counter. So to do this, I'm going to type game object and then last life, and this is going to be lives, and we want to get the last one from this. Okay, even though we're going to use an array operation, it still works with lists. It's still a collection, so we can access the last element like this. Here I'm going to add lives.count minus 1. We don't use length here, by the way, we use the property count. Minus 1 to get the last life here. Finally, I'm going to type lives.remove last life. Okay, this list here no longer needs to know what is this life, and it doesn't need to know because we're going to destroy it. So we type destroy last life like this. Okay, so that's the logic for losing life. Number of lives minus minus, we take it off, remove, and destroy. And there's one important thing we have to check. We need to check if the game is over. So we're going to add here if number of lives is lesser or equal than 0, then I'm going to hide the text, so score text dot set active is going to be false, and we're going to print the message with debug.log game over, just so we can see if things are flowing correctly. Now some people might ask, why am I checking if number of lives is lesser or equal to 0 instead of just checking if it's 0? Maybe later in your game you want to add bombs that take more than 1 life point. So when you do this, you're going to make sure it's going to, well, if you have 1 point and you lose 2, it's going to be -1, which is still death anyway. So that's why it's interesting to cover these scenarios as well. Okay, so let's save this. We go back to Unity, wait for the compilation to be done, and in this life counter I'm going to use number of lives 3 the live prefab is this one here. The score text is this one. We're not going to use game over group for now. But now we can go to the cuttable object here, and if we are dealing with harmful elements, we're going to type GameObject.find, and between parentheses we're going to search for live counter dot transform dot get component, and again of type live counter, which is the class that we just made, dot lose life. Okay, just like we did with the score, we search for the life counter and we call something in it. Okay, so we save this script, go to Unity, let's wait for the code to be ready and give this a try. Okay, so code is ready, let's press play. First thing, let's look at the interface. We have 3 swords. If we stop this and change this number of lives to 4, we should see 4 swords. Okay, it's going to update dynamically for us. So 4. Okay. Let me move it back to 3 just so it's going to be quicker for us to lose the entire level. Okay, so back here, I'm going to destroy some pineapples, score 10, 20, and a bomb. Then I lose a life. Okay, we got the last life that has been added, which is the one on the leftmost part. We remove it. Now we just have 1. If I destroy this bomb, no longer we have lives and the score has been hidden. We do this because here we're going to show a game over message. It's the next step on finishing this game logic. Okay, but we almost have everything ready here. Okay, we have an entire game going on, entire score, and now that we have this, we should basically do the game over message. We're going to do this in the next video. Alright, so to finish this up, we need to work with the game over group. We're basically going to add a very simple text here. So in the canvas game object, I'm going to right click, choose create empty. We have this game object here. Let's make sure it's the position 0, 0, 0. I'm going to rename this to game over group, and we just want a text inside this. So right click, UI, text, and let's leave it like this, text. Okay, let's resize this. I'm going to click here, hold the Alt or Option button to resize it. It should be a big text like this. And we're going to do a very simple message here. Game over, your score was, and then between curly braces 0, and click to play again. You're going to understand why we're going to use this soon enough. Okay, let's change the font to our custom font. The font size, let's use 70 might be too much. Let's use 60. The color is going to be white. Let's align it centered horizontally and vertically as well. Okay, so this is the game over message. Right now, let's go to, let me see here, to the live counter. We're going to grab this game object here and drop here to the game over group. Let's also rename this to game over group. Good. And what we want to do is, let's go to the script of the live counter, and whenever this begins here in the start method, we're going to hide the game over group. We want to ensure it's not going to be visible. So game over group dot set active, and it's going to be false. And here, whenever we reach the game over, we're going to come here and type game over group dot set active, and we're going to set it to be true, like this. Let's save the script and let's see what's going to happen now. Okay, let's make sure everything is going to be visible. Let's wait for the code to compile, and we're going to press the play button. Okay, once we do this, we have score 0, we have the lives there. Let's destroy some fruits, 1, 2, and destroy 3 bombs. Let's wait for another one to come, this one, and one more bomb, and should see the finishing of this. Okay, last one. Okay, so you have this, game over, your score was this, click to play again. So what should we do to update this with our score? Okay, so here in the game over group, this is what we're going to do. We need to access the game over text, and to do this we also need to access the Unity Engine's UI. So using Unity Engine.ui. Now down here I'm going to put text. Game over text is going to be game over group dot get component in children. We're going to find this component inside the hierarchy of the game over group. Remember, the game over group game object doesn't have a text component, but the text inside it has a text component, a text script. That's why we use get component in children of type text, like this. Now, what we're going to do, we're going to type game over text dot text is going to be, and to replace that 0, we're going to type string dot format. We're going to pass game over text dot text as the first parameter, and the second one is the argument to replace the 0. Okay, so here we need to fetch the score. And how do we get the score? We're going to type here int score is going to be game object dot find score text dot get component of type score text dot score. So here we type score. Okay, so what did we do? We got a reference to the text of the game over here. We fetched the score value here, and now we replace the game over text. We're going to update the game over text with this score as a parameter. Okay, notice that this has 0, but we could add 0, 1, 2, 3, 4, and then keep adding different parameters here to format this string. We're basically doing a series of replacements to update the text that we have. Okay, let's try that one more time, but I'm going to use just one life this time. Okay, so it's going to be easier to test. We now press play. Okay, let's wait for things to appear. We have one fruit, another fruit. I'm going to destroy this bomb, and we have game over. Your score was still 0. So notice that there was a problem here. Object reference not set to an instance of an object. So let's see what might be missing here. If you double click on the life counter, and this is pretty interesting by the way, you will notice here that it's saying that this is null. So this couldn't be found before this because the score text was already set as inactive. Okay, so I'm going to move this from here to here because we no longer are going to use this text. Okay, we try that one more time. Let's save, move back to Unity, we wait for the code to be ready, and after that we're going to press play. Let's wait a little bit. Okay, so we have a fruit here. Let's destroy this one as well. The bomb, once we destroy it, there we go. We have game over. Your score was 20, and click to play again. Okay, so good. Now we have a lot of things here. If you want to improve how this text is being drawn here in text, you can add some interesting tags. I'm going to change the font size to 70. But here where it says your score was and 0, we can type it like this. Size equals to 50 or 60, and here we add backslash size. So this text is now smaller. We can make it even smaller here. Size equals to 35, and then we close this size tag. It's like we are developing an HTML page. Okay, here you can force sizes to be differently. It's called rich text. Okay, so it can look like this. Game over has the font size 80. Your score was this 0, 60. Click to play again 35. So it looks like this. You don't have to make 3 different text views. Just one with these rich text tags is going to suffice. Okay. And once we have this done, we need to make sure we are able to play again. Okay, so to do this, we're going to need an update method. So void update. And in the update, we're going to check if number of lives is less or equal to 0 and input.get mouse button down 0. That means we are touching this. Okay, that means we are clicking to restart. And if this happens, we're going to need to use a scene manager like we did in the title. So using Unity engine.scene management in the top of the code, and back here we're going to type scene manager.load scene, and I'm going to type game here as a parameter so we're able to load the game scene. Back to Unity, let's wait for the code to compile. We're going to press play one more time. And once we do this, let's see things flying around. Okay, one fruit, we're going to have another one. There we go. The bomb, if I do this, game over, score 20, click to play again. If I click, we go back to this, okay, to the game scene. We should go back to the title, by the way. So let's change this text to title. And it's going to work the same way when you press the play button. Just move back to another scene and you can change options, well, see any other messages you want. I think it's better to move back to the title instead of just repeating the game. Okay, click back to title. If you want to play again, just press play. Okay, so we have the entire game ready. All right, we have game over, we have spawns, we are able to swing the sword and do some cuts. So pretty much the game is done. But there are some adjustments that we can make to this game to improve the code. We're going to do this in the next video, so make sure you save everything and let's get going. Alright, so let's move on to our final lesson. We're almost done. We actually have an entire game ready, but we should improve how the communication is working here a little bit. We have a lot of communication that is not entirely perfect, okay, not entirely good actually. For example, if you go to the cuttable object needs to find an interface element, the score text. It also needs to find where is the life counter. Okay, the life counter itself needs to find the score text. So this kind of flow of information is not very good. And using this find method, there are several downsides to this. If you change the name of the game object, for example, to something else, then it's going to be broken. It no longer works. So what I highly recommend you to do is to make a controller for this scene, and this guy is going to be responsible for storing the score, for saying that the game is over, and doing other things. So here in the hierarchy, I'm going to right click, create an empty game object. I'm going to make sure its position is 0, 0, 0. This game object is going to be scene controller. Okay, and what I'm going to do is I'm going to select the sword, the bomb spawner, the fruit spawner, and the main camera, and I'm going to grab them all inside the scene controller. Okay, I do this because I want to make it clear that this game object here is going to control the entire logic for the game, some high-level rules. Now, in the scripts folder, in the game folder, I'm going to right-click, choose Create, C# script, and I'm going to name this game scene controller. Let's hit enter, wait a little bit, and I'm going to choose the scene controller, select this here, and drop it here. Alright, so let's make some improvements. I'm going to open the game scene controller, and this is going to need references to a few things. I'm going to add public object spawner fruit spawner and public object spawner bomb spawner. Okay, we're also going to need references to the score text and to the life counter. So public score text, public life counter, life counter. Let's make some headers as well. So header gameplay, and here header interface. Okay. Also, this is going to have a reference to a score. So private int score equals to 0, and we're also going to have a certain amount of lives. So here public int, let's see how we used in the life counter. This is named number of lives. So okay, int number of lives, and let's leave it like this. Okay, so this is what we have for now. We need to make a few things here. Okay, so the method that we have here for lose life in the life counter needs to be moved to the game scene controller. Okay, so we're going to make here a public, let's make it private for now, private void lose life. Okay, whenever we lose a life, we're going to type life counter, actually amount, let me see what's the name here, number of lives. So number of lives minus minus. If number of lives is minus equals 0, then it's going to be game over. Okay, so we're going to do a few things. Let's remember what we have to do. Here we are going to get the game over group and set it as active. Okay, we're going to take off the text that we have, the score text, and do other things. Okay, so let's do things one by one. Here, score text dot game object dot set active, and we set it as false. Okay, we also need a game over group, so I'm going to put public game object game over group. Okay, here we set game over group dot set active to be true. Okay, we're going to do, you're going to see what we're going to do, what we're going to do here soon enough. Okay, let me copy this from here, and I'm going to put in the start method as well. Game over group dot set active false. Okay, good. So when we reach this level here, we need to update the live counter. Okay, we need to update the game over text as well, and update the live counter. I'm going to copy these things here, these 3 lines. I'm going to the game scene controller and paste them here, and I'm going to put update game over text. Okay, I'm going to add at the top the namespace using Unity Engine.ui and also using Unity Engine.scene management. Okay, let's give it a little line break here. Good. So what we have here, first we need to access the game over text. Since we have a game over group set here, we're going to access it. Now the score, we don't need to do it like this because the game scene controller is going to control the score. So the score is actually here. Okay, it's this value here. Okay, and we update the game over text to show it like this. Okay, and in the update method we're going to put the restarting logic, which is this one. I'm going to copy this, and in the game scene controller I'm going to paste it here. If number of lives is less or equal to 0 and input.getMouseButtonDown is 0, scenemanager.load scene title. Okay, so the live counter no longer needs this update method, okay, which is good, right? Now what we want to do in the game scene controller is, instead of managing the game over group, we don't want it to do this anymore. This is not going to have a game over group, it's not going to have a score text. Okay, it doesn't even have a number of lives anymore, and you're going to see why soon enough. Okay, so I'm going to take it off. Let's just delete it like this. Good. And now we only have the live prefab, the lives array. So instead of using a start method, we're going to rename this as set lives, and here I'm going to put int amount as a parameter. Here I'm going to put amount. Okay, this is what we're going to do. We're going to have this set lives. So in the game scene controller, right in the beginning here in the start method, I'm going to put live counter dot, let me just save this script, and here we're going to add dot set lives, and I'm going to pass number of lives as a parameter, number of lives, like this. Okay, and whenever we call lose live like this, basically we're just going to remove the live image, the live game object that we have, the last live. Okay, so I'm going to take all of this off as well. So the best way to do this code is making the live counter worrying just about the interface, just about the live counter that we have. That's why we just have the live prefab. We instantiate the amount of lives needed, as we see here in the set lives, and whenever we lose a life, we remove just one icon there. Okay, so I'm going to save it like this. Here in the game scene controller, we have live counter.set lives. This needs to be public, so it can be accessed. Okay, and back in the game scene controller, this now looks good. Okay, and whenever we lose a life like this, I'm also going to type live counter dot lose life. Okay, we call this so we update the interface correctly. So basically 2 steps: set the amount of lives and take 1 life whenever we should lose a life point. Okay, so the life counter is much better now. It looks like this. As for the score text, we need to do this differently. Okay, the score text actually, I think, yeah, we're not going to do anything with this script anymore because the game scene controller is going to manage this score text. Okay, so what we're going to do is we're going to get this property here. Okay, we're going to copy this from here, and in the game scene controller I'm going to paste it here. Okay, so it looks like this. When we use the getter, we return the score. When we use the setter, we set the score. But here I'm going to type, instead of get component text, we already have a reference to the score text. So this is score text.text equals to this. Okay, I'm going to rename this as text to use the Unity interface so it works correctly. Good. score text.text equals to this. And in the start method, we're going to set score with an uppercase S equals to 0. Okay. Once we do this, we no longer need this score text. Okay, I'm going to close this. I'm even going back to Unity. I'm going to delete that from the score text. Okay, so let's open the canvas, score text. I'm going to remove this script, and I'm even going to delete it. Okay, we go to the UI folder. We have the score text here. Let's get completely rid of it. Okay, we delete. Set a delete, good, okay, because the game controller is going to manage everything. But now you're going to see that there is a problem here. The cuttable object is trying to update the score text and the life counter, but this needs to be completely rewritten. Why is that? It's a very important practice for you to make sure, and I'm repeating that, I've told you that before, to think about the communication, about things needing to know what other things are. Cuttable objects, they don't need to know what is the life counter. It doesn't need to know what is the score text. The game scene controller needs to know what are the cuttable objects, and they need to understand when these cuttable objects they are destroyed. Okay, this is the most important thing here for you to understand. The game scene controller is going to listen for when cuttable objects are destroyed, and when they are, then the game scene controller is going to do something. It's going to increase the score, or it's going to lose its own life points. This is the kind of communication that makes a game looks very good, okay, that behaves correctly. It's going to be easy to expand, and then, well, you're going to be able to expand this game and have very little trouble. So in the next lesson, we're going to learn how to do this communication, which seems like an advanced topic, but it actually isn't. It's actually pretty simple. Let's do this in the next video. Okay, so to make the communication work properly here, we're going to use some events and delegates. There is no need to go in depth on this, but basically we're going to define a signature for an event, for something that happened over time, and then this is going to be listened by a certain object. This is what we're going to do. Here in the object spawner, we need to define a delegate, so this is going to be public delegate. Now we're going to define a method signature. It's going to be void because it's not going to return anything, and I'm going to name this object spawned and then handler. Okay, this is the method signature, and here I'm going to add a codable object as a parameter. Okay, or let's name this obj like this, so the name object is a reserved keyword. And now I'm going to define public event object spawned handler, and then on object spawned. Okay, so this is an event here, and what we want to do is whenever we spawn an object here, we want to communicate to everyone that's listening for this event that this spawn happened. So here in the spawn method, I'm going to type if on object spawned is different than null. That means if someone is listening for this event, I'm going to raise this event to inform everyone that an object has been spawned. And remember, we have to pass a parameter here. We need to pass a cuttable object. Here we're going to type instance.getComponent of type cuttable object as a parameter. Okay, so that's pretty much how this signature is going to look like. Now in the game scene controller knows what are the spawners, which makes sense. Spawners do not need to know who is the game scene controller, but the game scene controller can know what the spawners are. Okay, so what are we going to do here? In the start method, we're going to type fruit spawner dot on object spawned plus equals, and here we need to pass our own method that is going to treat this. I'm going to make it right now. I'm going to type private void. I'm going to use the same name, on object spawned. The parameter is going to be cuttable object, and I'm going to name this obj. Okay, so here I'm going to type plus equals on object spawned, just like this, the same name. It could be any other different method name if you wanted, as long as this signature here is the same as the one on object spawned. Okay, the same as the delegate that we have defined here. I'm going to use the same name just to keep things simple. Okay, now we do this for the fruit spawner, and we also do this for the bomb spawner. Okay, so what are we going to do now? We're going to do another set of the delegate event, but this time inside the cuttable object. Why is that? We want to put the event, we want to understand whenever something has been destroyed. Okay, so I'm going to add here a public delegate. Now the method signature is void object destroyed handler, and I'm going to add here a bool harmful. Okay, just like this. And now public event of the delegate type object destroyed handler, and this is going to be named on destroyed. Okay, on destroyed, just this. Okay, good. And now here in the on collision enter, when we destroy game object, okay, we could even do this before just to make sure, and we're going to ask if on destroyed is different than null. That means if someone is listening for this event, then we're going to say on destroyed, and the parameter is going to be harmful. Okay, so we can get rid of this. So on destroyed and harmful. Harmful is that public Boolean variable that we defined before. Okay, so we're basically going to communicate that this has been destroyed, and we can inform if it is harmful. So what do we do now? In the game scene controller, we know when an object is spawned, but now we need to know when an object is destroyed. So I'm going to add here private void on object destroyed, and here bool harmful, like this. And whenever we receive this, I'm going to type obj.onDestroyed plus equals onObjectDestroyed. Okay, so basically this event is just for us to know what has been added to the game, and then we signed to another event onObjectDestroyed. And finally, when onObjectDestroyed is called here, we check if not harmful, then we can increase our own score. Score plus equals 10. Else, so if it is harmful, then we call the method lose life, like this. Okay, so we save, and so look how the life counter is much simpler now. How the cuttable object is also simpler. We just destroy it and we inform if something has been destroyed, and how we don't even need the score text anymore. Okay, so let's give this a try. We're going to save this. There were lots of changes here, so let's take a look if there are any errors here. Apparently not. So we're going to the scene controller now, just a few things. I'm going to set the number of lives to 2. Fruit spawner goes here. Bomb spawner goes here. Good. Score text is this one. Good. Life counter is this one. And game over group is this one. So let's test the entire game again. Let's press play. Score is 0. We have 2 lives, so we can properly communicate with the interface. Let's destroy a fruit. Score still updates to 10, 20. This is perfect. Everything is going well so far. We're going to destroy a bomb. We lose 1 life. Good. 40. Let's destroy the last bomb to see if game over works. Perfect. Game over. Your score is 40. Click to play again. If I click, everything is working just as before. So some of you might be asking why the necessity of spending these 10-20 minutes talking about this. I can't stress enough how important it is for you to understand this event system. Okay, remember, when you get to the cuttable object and you try to search for the life counter or try to search for the score text, it's just so easy to make mistakes when you do this. You can remove something, maybe you change a name, then you have to change on something else. Your code is going to be highly connected, and this is not very good. Okay, whenever you have a game object that has access to several different ones of them, when there is no hierarchy involved whatsoever, problems are going to happen. This is a small game, but if you make big games, these problems, I can assure you, they are going to happen. So make sure you understand this event system well. Okay, maybe play these lessons again, maybe try to find the C# reference for events, but this is very, very beautiful. It works very well, and it's very, very simple. You make sure components do exactly what they're supposed to do, instead of making the life counter to restart the game, for example, and you make one nice game scene controller game object and script to control all of these things. Okay, we can even come here in the life counter and remove this scene manager we don't even need UI as well, so we can remove this. Okay. The cuttable object is fine, just destroys itself. Start is complete, okay. Object spawner, it's also about the gameplay, move object, okay. So pretty much everything is done here and we finished this lesson, okay. So this is it. I hope you enjoyed making this game. If you want a challenge to improve this game a little bit, you might want to make the interval for spawning bombs increase over time and also throw multiple fruits at once. Maybe you don't just want to add one fruit or two fruits at a time, but maybe even more. This is going to make the game even better and the players are going to have much more fun with this. Okay? So, this is it. My name is Glauco Pires. Thank you very much for watching and I see you next time. Goodbye.